Hello everyone, today we talk about bases. Do these vectors form a basis? First of all, we determine what does it mean, basis. A set of vectors in a vector space V is called a basis of V if it is linearly independent and it spans V. What is linearly independent vectors? The columns of a matrix is linearly independent if there is no linear combinations that gives a zero vector. Columns are independent if null space is only a zero vector, so no free variables and rank A is equal n. Columns are dependent if AC equals 0 for some non-zero C in the null space, so rank A is less than n, where n is a number of columns. Independence or dependence is exactly what null space says for us. In each set of vectors, we can span some column space. Are they independent? They can be. The point is that we are looking at such vectors that span a space, and they are independent. What are the main steps in checking that a set of vectors form a basis? We have n vectors. At first, let's notice that they anyway form some vector space V. First, put vectors in the columns of a matrix. Second, do elimination. Third, you would see if you get any free variables or all columns are pivot columns. If you get no free variables and a pivot in each column, so the columns are linearly independent, so they form a basis for the vector space V. If we have n by n matrix, so really what we ask if our matrix is invertible. For Rn, n vectors give a basis if the n by n matrix with those columns is invertible. Example in R3. Let's take such three vectors. They are certainly linearly independent because the only way to solve AC equals 0 is a zero vector C. The point is that we can span the whole R3 by taking their linear combinations, so V1, V2, V3 form a basis for R3. No doubts, you can find another basis for R3. Note that vectors V1, V2, V3 form a 3 by 3 identity matrix. Let's take one more example. One more example in R3. Due to our steps, first we have columns of our matrix. We do row reduction. There is no free variables, so the columns are linearly independent and they span whole R3. Why is it important? First, number of vectors for different bases is the same, and it is a dimension of that common vector space. Second, the number of vectors in bases is just right. If I didn't have all of them, I wouldn't have my whole space. If I have more of them, they wouldn't be independent. And the last one, it has a great link with square invertible matrices. Thank you for your attention, good luck and have a fun!